Okay, here's one word problem that some of you might not get, but I'll go over it anyway just because you'll have to know these things on the test. I guess they assume that you understand how to do physics or you taking physics concurrently with this, but let's try it anyway. Jim filled a water tank shown to the right at the rate of 4 cubic meters per minute. So let's write that down. The rate is 4 cubic meters per minute. Now, the way I'm writing these rates is how physicists do it. So this is how you would do it in physics class. Okay. Now you're gonna do it for 6 minutes. 6 minutes. So you're kind of looking at the volume and the height in which it's being increased. Okay. So I don't have a solution for this, but we'll work on one. Okay. So then he turned off the water and took a break for 2 minutes. When he returned to fill the tank, it only took 1 minute. Sketch the height of the water, ht, as a function of time. Okay. Height would be ht over here, function of time. Then over here would be time down here. This is your height in meters. Okay. So let's just put some values to this axis here. 3, 6, 9, 3, 6, 9. Okay. And over here, I'll put 1, 2, 3, 4, something like that. 5. Okay. Now, if you're going to have a rate for 4 cubic meters per minute for 6 minutes, what I'm going to do is turn this into a volume. Okay. You have 2 meters, 2 meter, 4 meters, 5 meters there. So let's turn it into a volume. I'll multiply that by 6 minutes because that's how long Jim is filling the tank. That would give us a total, cancel out the units. So I hope you learned this in physics. You would be left with 24 meters cubed, which would be your total volume after 6 minutes. Now, if you look over here, the surface area on the bottom of this rectangular what do you call those things? Rectangular prism is 2 by 4. I would assume that those are right angles there, so they go straight up. So it's 8. The area is 8 meters squared. So for every meter up you go, it's 8 meters being filled in this rectangular prism. So this one here, the volume, the total volume for that first pour was 24 meters cubed. And this, if you go 1 up, it's 8 meters. If you go 2 up, it's going to be 16 meters. You go 3 up, it's going to be 24 meters. So essentially you're going like this. Let me just mark the points. this is 18. Oh, wait a minute. Hang on for a second. Okay, I'm back. So your volume is going to be at 24 cubic meters. Okay, so he's running 6 minutes, and in those 6 minutes, the volume is 3 meters high. He went once, which is 8 meters cube. Then he went one more meter higher. That's 16 meters. Then another, that's 3 meters up, which is the height over here. That's 20, gives us 24 meters cube. Okay, so let's draw this line here where he started filling that tank. Okay, so that's our first fill. After that, he took 2 minutes to took a break, right? 2 minutes. So then it goes horizontal, 2 minutes. There we go. Then what happened after that? And to fill it, it took him only 1 minute. So to fill it, that means he went all the way up to the top, 5 meter distance right here. So where's 5 meters? It's up here. It's the 5 meter line, but he took only 1 minute. So we ended at 8 over here. Is 8 right there. Okay. But he took 1 more minute and he ended up here at the 5 meter mark. So let's draw that line again. Okay, it would be just like that. Okay. All right. Let me pause the video for a second. Okay, students, we're moving on to page 82 right now. Page 82. Okay, let's read through this. Choose dimensions for the rectangular prism below. Use feet for the units for each dimension of the prism. Choose 2 rates in cubic feet per minute, which is written feet cubed divided by minutes, that you would like to work with. To fill the first half of the container, water will be pumped into the container at rate 1. Then to fill the second half of the container, water will be pumped into the container at rate 2. Create a graph that shows the volume of water in the container over time. Label axes indicate the scale used for each axis. So volume over time, so I already wrote those values in, time and volume, okay, for the x-axis, y-axis. So let's see. To make things easy for us, I'm just going to call this, so we're kind of just creating this problem. It's like a word problem, like a real life situation, okay? But to make things easy for us, I'm going to call H2 2 feet, just to make things easy for us and the calculations. The width can be, you know, like 3 feet. Length can be 4 feet. Hopefully it comes out easier. Water will be pumped into the container at the following rates. Well, I'm going to try to make it easy for me. Knowing that the height of 1 foot of water which is half of this length right here, 1 foot of water would be 3 times 4 would be 12 feet, 12 cubic feet. 1 foot of water would be 12 cubic feet. And we're talking about volume, so let's label the axes. Okay. I'm just going to do like this. Go by units of 12. Okay. Maybe I'll call this 6 here. Call this 12 here. Call this 18 here. Call this 24 here. I'm not sure if I'm going to use all of that, but just let's go with that. 12. Okay, I guess I will. Okay. Time. We're looking at 2 different rates. Okay. 2 different rates. So first, to fill up the first half of the container, let's call these minutes. Yeah, feet per minute, right? Yeah. Let's call this just call this minutes. See how that works out. Okay. Okay, you gotta take a stab at it, even though you're not sure sometimes. So that's what we'll do. Let's say the first rate to fill the container. You gotta select the rate. To just say, well, you gotta select the rate. Okay. What if I select something like this? 6 cubic feet per minute. And the last part is 12 cubic feet per minute. So how would that look as a graph? Okay. Let's try. Okay. So if this is 2 right here, the height is 2. So that would mean the height of that is 1 foot. Okay. 1 foot. The base would be 12. Okay. So I can see that. So rate filled 6 cubic feet per minute. Let me use a scratch paper. Let me use a scratch paper, okay, guys? 6 feet cube per minute. Okay, hang on for a second. Just hang on for a second. Let me see. Okay, sorry, folks. I had to do some mental gymnastics there. So if the water flow is flowing into this container up to the first foot level, which is 12 cubic feet, um, at 12 cubic feet, and if you're flowing it at 6 cubic feet per minute, then it'll be 12 um, 12 divided by 6 is 2. It'll take 2 minutes. So you mark the 2 there. Now, if that volume went up to 12 cubic feet per minute, which is twice as much, it would fill it twice as fast. The slope would be twice as steep. And once it reaches the top of this box, this rectangular prism, at 2 feet high, the total volume in here would be 24 cubic feet. So I marked these points over here. This is the 2 minute mark. This is the 3 minute mark. So your graph is going to be something like this, okay? And it goes up. Something like that. And then your rectangular prism container would be full. So I tried to select rates and size of the rectangular prism so I could have kind of easier calculations just to show you here. So it take 2 minutes, it'll fill it up 12 cubic feet, which is half this box. In 1 more minute, because it filled up twice as fast, it went all the way to the top at 24 cubic feet in 3 minutes. I mean, in a total of 3 minutes here. 1 more minute here, but total 3 minutes, okay? So I hope you guys got that. Good luck on the test tomorrow. Remember, I told you we have only 3 more weeks of instruction, and we're going to be done with this book and the whole semester. So it's getting down to crunch time. If you're falling behind in this class, I would recommend 2 hours a night. And if you don't do that, well, that's on you. Just think about it. If you want that good grade in this class, you got to put in the time and the effort. You cannot be goofing around because we just got 3 more weeks, okay, guys? Good luck on the test tomorrow. I'll see you tomorrow. Good night.